This is a demo video, and is designed to instruct without a calculator, just to remind you what we are doing with pretty numbers before we jump into it with the ugly ones. The problem is 3 root 2 cosecant squared theta minus root 2 equals 3 root 2. First, add root 2 to both sides of the equation. Then, divide both sides of the equation by 3 root 2. Then, you square root the cosecant squared and the 4 over 3 to get regular cosecant and 2 over root 3. Do not forget the plus or minus. To get the equation in a better form, you want to switch cosecant to sine. To do that, you invert the plus or minus 2 over root 3. That just means that you flip it, and it becomes a sine. Now that you have sine theta equals plus or minus root 3 over 2, we suggest drawing a unit circle, on which you draw a triangle, or rather 4 triangles, with reference angles of 60 degrees. This shows all 4 of your answers. There are many ways to write the answer to this equation. If you are paranoid, you will include all of the triangles in all 4 quadrants in your answer. This means pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Since there is no domain restriction, you have to add plus 2 pi n to the ends of all of your answers. If you are slightly less cautious, then you can only put 2 triangles and say plus pi n, since that only gives you half of a revolution. Therefore, you still cover an infinite amount of triangles with half the time. Just make sure that those triangles are not diagonal to each other. Lastly, you can just take your first triangle and put plus or minus in front of it, and then say plus pi n. That way, you can include all of your triangles as efficiently as possible. On to the next problem. This problem has ugly numbers in it, so get ready. The equation is 2 secant squared theta minus 8 equals 6. This one does have a domain, so we won't include the plus 2 pi. But don't forget about it, since we will return to that in a bit. The domain is 0 to 2 pi. The first thing you want to do is add 8 to both sides. Now, divide by 2 on both sides. You're left with secant squared theta equals 7. Now, take the root of both sides. Don't forget that plus or minus. Now you have to convert your equation to a better form. This means that you have to flip your equation and turn your secant into cosine. This leaves you with plus or minus 1 over root 7. Now draw your unit circle. Draw one line in each quadrant to remind yourself that you should have 4 answers at the end. Enter the inverse of cosine onto your calculator. You should have cosine of 1 over root 7. Then store that answer, because you will need it later. We will use x, but you can use whatever letter that you want. This number also happens to be your answer for quadrant number 1. To get your answer for quadrant number 2, you simply subtract your number from pi. To get your answer for quadrant number 3, add pi to your number. To get your answer for quadrant number 4, you simply subtract your number from 2 pi. The third problem is 16 secant squared theta minus 23 equals 2. First, you add 23 to both sides. Now, divide both sides by 16. Now, take the root of both sides. Don't forget that plus or minus. Now, flip your equation so that you get cosine theta equals plus or minus 4/5. Now, you need to enter your inverse cosine into your calculator. Now, store that number. That number is your quadrant 1. Since there is no domain restriction, add your 2 pi n. For your second quadrant number, subtract your number from pi. This gives you 2.498 plus 2 pi n. To get your third quadrant number, simply add your number to pi. To get your fourth domain number, fourth quadrant number, subtract your number from 2 pi. Since we are being super cautious, we wrote this out the long way. But don't forget that you could just write plus or minus 0.644 plus pi n if you wanted to. The last problem is 3a. We're doing this problem to show you what a modified domain looks like. This problem has a domain that goes from pi over 2 to 2 pi. So draw your unit circle first this time. Tricky domains are always confusing, so you really want to make sure that you know where your lines are. In this case, you cross off, or shade in, just the first one. Now, add 8 to both sides. Now divide both sides by 4. Now take the root of both sides. Don't forget that plus or minus. Okay, flip your fraction so that you have sine. Now take your calculator. Okay. Now find your first number. Inverse of sine of 2/3. Okay, so that would be your first quadrant number, but that's outside of our domain, so just store it. Now, subtract your number from pi. That gives you your second domain, second quadrant number. But it's the first number we actually write down. Now, add your number to pi. This gives you your third quadrant number. Now, subtract your number from 2 pi to get your final fourth quadrant number. And that's it. You should be able to do the rest of these problems by yourself now. A complete answer key will be shown. Pause the video if you need to check your work.